In this video, we analyze some formulas concerning various Ramanujan series for estimating the value of pi. We describe the new possible mathematical connection with the Ramanujan recurring numbers, the Dn constant, and some parameters of string theory. Let us remember that by Ramanujan's recurring numbers, we mean the following numbers: 1729, 4096, pi, and pi squared over 6, and the golden ratio. We analyze the following formula. We have the following expression and the following result, that is equal to pi. This result that is equal to pi. We obtain the following property of the above formula. That is the result is a transcendental number, the alternate forms, the expanded logarithmic form, the reduced logarithmic form, the alternative representation, the series representation, the integral representation. From the following approximation to pi, we consider the following expression, from which we obtain the following result. Result that is a very good approximation to pi. Also, for this formula, we have the following property. Practically is a transcendental number, the alternate forms, the expanded logarithmic form, the reduced logarithmic form, the alternative representation, the series representation, the integral representation. From the following approximation to pi, we obtain the following expression and the following result, that is equal to a result that is a good approximation to pi. We have the following property. The result is a transcendental number, the alternate forms, the alternate forms, the reduced logarithmic form, the alternative representation, the series representation, and the integral representation. From the following approximation to pi, we consider the following expression okay, and the following, from which we obtain the following result, that is equal to pi. The property is a transcendental. The result is a transcendental number. We obtain the alternate forms, the expanded logarithmic form, the alternative representation, the series representation, and the integral representation. Now, from the following approximation to pi, we consider the following expression, from which we obtain the following result, that is equal to pi. The property is a transcendental number. The alternate forms, we obtain from the previous expression the alternate forms, the following alternate forms, the expanded logarithmic form, the alternative representation, now, multiplying the first two results, alternate forms that we have previously analyzed, we obtain the following expression, and from which we obtain the following result. Result that is a very good approximation to the pi squared. Step by step, we list the various properties of the expression analyzed above, practically the alternate forms. We obtain the alternate forms, the reduced logarithmic form, that is the following, the alternative representation 1, 2, and 3. Okay. The series representation 1, 2, and 3. And the integral representation 1, 2. Multiplying the other two results, alternate forms that we have analyzed previously, we obtain the following expression, from which we obtain the following result. Result that, as above, is equal to p squared. Also here we list the various properties of this expression. Choose the alternate forms. The reduced logarithmic form. The alternative representation. One, two, three. The series representation. 1, 2, 3. The integral representation 1, and 2. From the following last approximation, we obtain the following expression, from which the following result, that is equal to pi. Also here we list the various properties of the expression analyzed, choose the alternate form, the expanded form. Okay, now multiplying the two previous result alternate form, practically this expression and this expression, we obtain the following expression, from which the following result that is equal to pi raised to the fourth power. Okay. Also here we list the various properties of this expression, choose the alternate forms, the alternative representation, now multiplying the previous result, practically this result that is equal to pi raised to the fourth power, multiplying this result for the following expression, practically from the last expression, choose pi raised to the fifth power, pi raised to the fourth power, by multiplied by this expression that is equal to pi, we obtain the following result, practically pi raised to the fifth power. Also here we obtain the expanded logarithmic form, the alternative representation, the series representation, the integral representation. Now, from the previous expression, after some calculation, we obtain the following new expression. We note that 13 is a Fibonacci number, 123 and 7 are Lucas numbers, and phi is the golden ratio. This is the new expression, from which we obtain the following result, practically a result very near to 4096, that is a Ramanujan recurring number that multiplied by 2 gave 8192, that represent the gauge group SO 8192, that is fundamental for the open bosonic string theory. From the previous expression, we obtain also, after some simple calculation, practically performing the square root of the previous expression, multiplying by 27 and adding the unity, we obtain this result. Result that is very near to the mass of candidate gluable F0 1710 scalar meson. We remember that 1729 is the so-called Hardy-Ramanujan number, that is a Taxicab number, as it can be expressed as the sum of two cubes in two different ways. And it is also a Ramanujan's recurring number. And again, performing the 15th root, to which we add the following regularizzer containing the so-called Marvin-Ray-Barnes constant, we obtain the following expression. This is the regularizzer containing the Marvin-Ray-Barnes constant. The following expression, and the following, from which we obtain the following result. A very good approximation to pi squared over 6, that is equal to zeta 2, that is, we hypothesize, is the trace of the instanton shape, and also this value is a Ramanujan recurring number. Also here we obtain from the following furthermore we obtain from the following formula from the previous expression and the following formula practically 1 over p squared over 6 multiplied 4 over 3, and performing the square root, we obtain the following expressions and the following result. Practically the result that is equal to 2 root of 2 over pi, 2 multiplied square root of 2 over pi, practically the value of del Gaudian-Ardelli constant, the n constant. Now, from the sum of the previous two expressions, we obtain the following expressions, from which we obtain the following result. Practically 2 times pi, that is equal to the value of a circle of unit radius. Pi plus pi equal 2 times pi. Also here we obtain the alternate forms, the expanded logarithmic form, the reduced logarithmic form, the alternative representation, the series representation, the integral representation. From the sum of the other two previous expressions that we have previously analyzed, we obtain the following expression and the following result, that is as above equal 2 times pi. Also here we obtain the alternate forms, the expanded logarithmic form, the reduced logarithmic form, the alternative representation, the series representation, the integral representation. And from the last expression, we obtain the following expression, from which the following result. Result that is equal to pi. Also here we list the various properties of the expression analyzed. Choose the alternate forms, expanded form, alternative representation. Choose. In conclusion, we obtain from the sum of the various previously analyzed expressions the following conclusive expressions that is equal to this result, that is a very good approximation to the value 5 times pi. 5 times pi. We note that by adding only the first two results, practically 2 times pi plus 2 times pi, we obtain 4 times pi. 4 times pi is equal to semiclassical entropy for a black hole, of a black hole, for m equal to 3 and L0 equal to 1, and d, practically the degeneracies, equal to a value that is the least number of dimensions in which the master group can act non-trivially. Also for this expression we obtain the alternate forms, expanded form, the reduced logarithmic form, from the previous result, practically 5 times pi, we obtain also, after the following easy calculation, where 89, 21 and 2 are Fibonacci numbers, while gamma is the Euler-Mascheroni constant. We obtain the following expression and from which the following result, that is very near to the mass of candidate gluable, scalar Mason F0 1710 and 1729. We remember that is the so-called Hardy-Ramanujan number. From this expression we obtain also, performing the 15th root and adding the regularizer containing the Marvin-Rayburn constant, we obtain the following value that is a good approximation to pi squared over 6, practically the value of zeta 2, that is a Ramanujan recurring number. Furthermore, from this further calculation, practically from the previous expression, subtracting the unity, multiplying by 1 over 27, and all the expression raised to the second power, and subtracting 4 over 5 arbitrary constant, we obtain this result that is a good approximation to 4096, that is a Ramanujan recurring number that multiplied by 2 gives 8192. Practically the gauge group SO 8192 that is fundamental for the open bosonic string theory. Now we have the application of the octahedron and the sphere. Practically a sphere inscribed in an octahedron. With regard to the volume of an octahedron and of a sphere, we have the following formulas: octahedron and sphere, where the radius is equal to Rs equal to L over Q. With regard to the ratio between the two above formulas, considering Rs equal to L over Q, choose the volumes of octahedron and sphere, and we obtain the following expression that is equal to the following result, from which we obtain the following result. Practically, the Gaudian-Ardeli constant, dn constant, equal to q root of 2 over pi. Also here we list the various properties of the expression. Practically 2 root of 2 over pi is a transcendental number. Also here we obtain the series representation. From the previous expression, practically the ratio between the two volumes, the octahedron and the sphere, we have the following expression, from which we obtain pi squared over 6, practically the value of zeta 2, by the following calculation: 2 over the ratio between the two volumes. This expression raised to the second power and multiplied by 1 over 3. We obtain this value, practically p squared over 6, that is equal to zeta 2, which we hypothesize to be the trace of the instanton shape, and this value, we remember that is also a Ramanujan recurring number. Also here we list the various properties of this expression. Practically p squared over 6 is a transcendental number. The series representation, the integral representation. Now we note that from the sum of the first nine numbers, excluding 0, 1, 2, 3, 4, 5, 6, 7, 8, 9, we obtain the following interesting formula. Okay? We observe that inside the formula there is the golden ratio, pi, the Marvin-Raybarn constant, the Euler number. From this formula we obtain the following result, that is equal to a value very near to pi squared over 6, practically zeta 2, also here we obtain the alternate forms, expanded forms, and from the following formula, practically taking the square root of the previous expression, which gives the value of pi squared over 6, we obtain these expressions, from which the following exact result: 6 multiplying the previous expression. All these expressions we performing the square root, obtain the following exact result, that is a good approximation to pi, that is a Ramanujan recurring number. Also here we obtain the alternate forms, the expanded forms. Now, from the ratio between the two volumes of the octaedron and the sphere respectively, multiplying by 2 times pi, multiplying square root of 2, we have as a result 8, value that is linked to the Ramanujan function that has 8 modes corresponding to the physical vibration of a superstring. We obtain also the series representation. Now we have also this further formula, practically multiplying the ratio between the two volumes of the octaedron and volumes of the sphere, multiplying by 6 times pi, multiplying square root of 2, we have the following result, practically the number 24. 24 value that is linked to the Ramanujan function that has 24 modes corresponding to the physical vibration of a bosonic string. Choose. We obtain 8 from this formula and 24 from this formula. 8 and 24, that is respectively 8 the modes corresponding to the physical vibration of a superstring, 8, and 24 the modes corresponding to the physical vibration of a bosonic string. This is a fundamental link, fundamental connection with the string theory. Also here we obtain the series representation. Furthermore, from the previous expression that we have analyzed, expression from which we obtain 8 raised to the fourth power, 8 raised to the fourth power, we obtain as a result 4096, that is a Ramanujan recurring number, and that multiplied by 2 gave 8192, practically the gauge group SO 8192. And as previously, after following calculation, performing the square root of the expression that gives 4096, multiplying by 27 and adding the unity, we obtain 1729. That is principally the Hardy Ramanujan number and Ramanujan recurring number. Also here we obtain the series representations. Now, this is a fundamental expression. We note that from the sum of the two expressions that give 1729 and 4096, after some simple calculation, we obtain the following expression. This expression is equal to 4096. This expression is equal to 1729. The sum of this expression multiplying by 1 over 25 and 1 over 144, we obtain the following result, practically 253 over 144. That is equal to the following result. That is a very good approximation to the value of the golden ratio. That is also a Ramanujan recurring number. Furthermore, we know that 233 and 144 are two Fibonacci numbers, and that their ratio, as for all the numbers of the Fibonacci series, tends to the golden ratio. Also here we obtain the series representations. 1, 2, and 3. Now, from the Delgaudian-Ardeli constant, the n constant, that is a transcendental number, practically 2 root of 2 over pi, we obtain also by this formula the value of pi, practically 2 over 2 multiplying square root of 2 over pi raised to the second power, multiplying by 1 over 3, this expression multiplying by 6 and performing the square root of the whole expression, the result is pi, precisely pi. Okay. Also here we have the various properties of the expression analyzed. Practically pi is a transcendental number. The roots of pi squared, the series representation, the integral representation. Furthermore, from pi squared over 6, we obtain by the following formula, practically 1 over pi squared over 6 multiplying 4 over 3 and performing of this expression, performing the square root, we obtain another result that is 2 root of 2 over pi, practically the Delgaudian-Ardeli constant, the n constant, 2 multiplied square root of 2 over pi. Also here we list the various properties of the expression analyzed, practically the Gaudian-Ardeli constant is a transcendental number. This is of roots, and this is the series representations. Now, from what is described in this video, we notice how from pi we obtain pi squared over 6, which is also the value of zeta 2, a value of the Riemann zeta function. The Gaudian-Ardeli constant, the n constant, from which we obtain 8 and 24, numbers linked to the physical vibration of superstrings and bosonic strings respectively, 1729, that is the Hardy-Ramanujan number, and 4096, from the sum of which, after some simple calculation that we have described previously, from which the golden ratio is obtained. It is plausible to hypothesize that pi and phi, pi and the golden ratio, in addition to being important mathematical constants, are constants that also have a fundamental relevance in the various sectors of theoretical physics and cosmology. When Ramanujan wrote the seminal work Modular Equations and Approximations to pi, did he think about what important developments he would make? Was he thinking about the connection with some parameters of the strings, such as physical vibration, and to the connection of pi with the entropy of a black hole and the area of the event horizon of a black hole? We believe that Srinivasa Ramanujan certainly understood the importance of his work and the future and the incredible consequence that this sublime and elegant mathematics will provide and still provide. This is the reference, practically modular equation and approximation to pi Greco, to pi, of Srinivasa Ramanujan, Quarterly Journal of Mathematics of 1940. This is a wonderful. An equation means nothing to me unless it expressed the thought of God. Wonderful. Thank you very much. Thank you very much over to Ramanujan, which inspired and inspired in my mathematical research. Thank you very much.